Hello, everyone. Good afternoon. Hope you managed to grab a lunch. Welcome to my talk, OpenTelemetry at Delivery Hero. Thank you. The good, the bad, and the vendor-agnostic. So who am I? I'm a principal engineer at Delivery Hero's developer platform, and I'm really a tech generalist. I've been doing backend engineering, data engineering, MLOps, DevOps, anything really except for client side. I also have a passion for exotic programming languages, and sometimes I do integrate them in critical systems in production. But in the past 2 years, I've been doing something else. I've been tech leading a global observability vendor migration project at Delivery Hero, and at the same time, the migration of telemetry ingestion infrastructure of Delivery Hero to OpenTelemetry. And this is our topic for today. So, quick heads up, all the materials for this talk have been prepared with the assumption that the audience is very familiar with the OpenTelemetry ecosystem. If it's not the case, just ask me anything after the talk, and I'll be happy to woman-splain it to you. So, what is on our roadmap for the next 20, 25, 30 minutes? First, this will not be a talk about success. I will not be showing you some dramatic decrease in observability cost. I will not be showing you improvements in MTTR or any other site reliability engineering metrics. And this will also not be a talk about failure. It will be a candid insight into the ongoing Delivery Hero's journey to becoming vendor agnostic. So we're going to have a look at the historical context that shaped this journey, and also the strategy that we have developed to mitigate some risks and problems that we experienced with the previous observability infrastructure. Also, we are going to have a look at the telemetry ingestion setup that we came up with, and the pains, the issues, and flaws of some of the OpenTelemetry ecosystem parts that we have experienced. So let's start. Before we dive deep into the weeds, I want to make sure that we use the same vocabulary, and I want to introduce to you a couple of connotations of the word platform that are used at Delivery Hero. So when we say platform, we mean all the cloud infrastructure that, so Kubernetes clusters, CI/CD machinery, observability agents, and all other things that constitute the infrastructure. And also, when we say platform, we mean the organizational unit that provides this infrastructure. And this is what you will see on the illustrations that I will show you in a bit. And also, there will be apps, applications written in the languages that are most popular at Delivery Hero, such as Python, Java, or Go, that are running on these platforms. So we're all set up. Behold the structure of Delivery Hero's infrastructure in its complexity. So to appreciate the challenge, we need to understand the unique historical context of Delivery Hero. It's a food delivery company that emerged through acquisition. That means it's a fish that consumed smaller or equally sized fishes over time, and in the end, it ended up being a giant blob that constitutes over 13 actually sub-companies at the moment, and we call them entities. And crucially, each of these entities came with their own platforms. That means teams that were developing and offering infrastructure to each of these parts of Delivery Hero, and also different observability setup that they brought with them. Some of these company parts were using different observability vendors, and they also integrated vendor-specific SDKs and agents into their systems. Other parts opted in for self-managed solutions, where they used and maintained a patchwork of open source components and systems such as Prometheus, Victoria Metrics, Grafana, Jaeger. Really name any of them, and we probably had it somewhere. And when the company started to design business processes that incorporated several of these entities, it was impossible to implement reasonable distributed tracing because spans for traces of different organizational units were stored in different backends. Also, we were in a vendor lock-in. That means that we instrumented everything with vendor-specific SDKs, had vendor-specific agents, and we couldn't move away from this. So this context, and also the ask of the CTO to please save $6 million per year, brought us to the decision to consolidate the platform and consolidate the observability tooling and to move to OpenTelemetry. And this is how our organizational strategy in this area emerged. So we decided that it's crucial for us to become vendor-agnostic, to eliminate the vendor lock-in that we had, also to democratize the observability through semantic conventions and standardization, and to focus on critical business operations represented through traces. And when we thought about these goals and we looked at OpenTelemetry, we realized that the majority of these goals is covered in the ecosystem. So it is kind of vendor-agnostic. It enables democratized observability through OpenTelemetry semantic conventions. And also, tracing is the first-class citizen because OpenTelemetry, as we all know, emerged from open tracing, and yeah, it's in the name. So the ideal setup that we have envisioned related to our future telemetry ingestion infrastructure would be very simple. We would have centrally managed infrastructure with the embedded OpenTelemetry collector agent. And there will be applications all instrumented. It's an ideal world. All applications would be instrumented with the OpenTelemetry SDKs. And they would be ingesting all of the telemetry through this embedded agent into a single vendor. So there was an infrastructural change that we wanted to do. And there was also a mind shift. So Delivery Hero engineers love logs. They love logs. They store terabytes of logs. They love logs with a long retention, and they just have a FOMO every time when somebody tries to take their logs away from them. So what we wanted to do is to change the culture of the organization and to show that every operation that has a beginning and has an end can be modeled as a trace. So infrastructural change and cultural change. These were the objectives for our migration. So to recap, a small observability team had to support cloud infrastructure migration of the whole organization, observability vendor migration, observability infrastructure migration, and also re-instrument application, all the applications with the OpenTelemetry SDKs. So we decided to make a trade-off and first focus on all the things infrastructure and do re-instrumentation next. And this decision, this trade-off, brought us to the state of the telemetry ingestion infrastructure that we are having today. And it looks like a zoo, and it's a zoo of the collectors. And let me introduce you to all of the animals that we have here. So we have a central Datadog collector, a rhino in the zoo, and this is the collector. This is a centrally managed collector deployment. And when I say deployment, I mean Kubernetes deployment that can ingest data in Datadog type into our new observability vendor. Then we also have the central OTLP collector. This is another OpenTelemetry collector deployment that can ingest data in OTLP format into our new vendor. Then we also have federated collectors, which are kind of close to the ideal setup that I've just shown on one of the previous slides. So it runs on the centrally provisioned infrastructure, and it can consume telemetry in several types, so it can work with Prometheus format, Datadog format, OTLP format, and it can ingest it to several systems, including our new observability vendor. Also, remember the platforms and multiple fishes. So we also have some parts of the company that still have their own dedicated infrastructure teams, and these teams also maintain their own collectors. For example, Glovo, this is a business unit of Delivery Hero in Spain, has their own collectors, and logistics business unit also have their own collectors. So this is the setup that we came up with that has been dictated by the historical context that we have at Delivery Hero. But this is not an ideal setup, and at some point, we want to kill all the animals in the zoo and leave only the federated collectors, and I'm allowed to say killing animals because I'm vegetarian. So we will just leave the federated collectors, and all other collectors will be gone. But yeah, this challenging and cumbersome collector setup was mostly due to the historical context and the organizational context that we have in Delivery Hero, but we also have encountered some interesting things with using OpenTelemetry, and my top 3 are summarized in the following section. So if you would probably ask any other engineer at Delivery Hero, they would have their own top 3. Maybe they would overlap. So, number 1, forking of contrib components. We started with forking. So the very first collector, the central Datadog collector that we had, we used the forked Datadog receiver. And we had to do it for the reason back then that the Datadog receiver only supported traces, and we needed support of all telemetry types because we were going to ingest through this collector all telemetry types that we had. So we needed to extend it, but then now the upstream version supports metrics, but we still cannot switch back because since then our normal sheep evolved to be in a terminator sheep as demonstrated in this illustration, and it also started to have a lot of logic that is very specific to Delivery Hero and we cannot use from the open source version. We also maintain a set of other forked components, for example, span metrics connector, Prometheus remote write exporter, Delta to cumulative processor, and also load balancing exporter, which is not on the slide. And the reasons are twofold. So the first, I already explained a bit, is related to a custom logic which is not integratable, or it doesn't make sense to integrate it into the open source version of these components. And also, the second reason is sometimes review cycles in the open source component are much slower than we needed to bring the features that we need into production. Yeah, and also not to mention that all of these fork components, they also make OpenTelemetry collector version updates very cumbersome. So each time the new collector version is being released, and if one of these components has also been updated in the new version, we will need to generate new patches of these components, and the release process might be a pain. So another pain I want to talk about is marshalling and unmarshalling of data inside the collector. So it's a data journey inside the collector. And I really want to demonstrate it using the example of the moving between houses. So you're moving and you're packing all your boxes, and then you have forks. You put all of your forks in one box, you put forks in it. You put all of your spoons in another box, you put spoons in it, and you do everything the same way with all of your cutlery and other belongings, the washing machine as well. And once you are in your new apartment, you want to unpack forks, you open the box with the forks, and surprise, there are forks in it. And the box fits all of your forks, so you need just a few boxes to migrate them from A to B. You also don't need to unwrap the boxes, the forks from anything, and also you understand, like you can save time and your own resources on unpacking, and maybe do something else in the afternoon because you're already ready. Now, moving between apartments the OpenTelemetry way. So imagine you're in the new apartment and you have a lot of boxes, and all of them are unsigned, and all of them are identical. So you open a random box, and you see wrapped items there. Are there forks? Are there spoons? Are there knives? Is there a washing machine somewhere? And then you start unpacking, and what happens is that you spend too much time, you get tired. Also, your box now fits only 5 or 10 elements instead of hundreds, so you the whole process gets very inefficient, and unwrapping creates a lot of garbage, so you need to clean up afterwards. And you spend too much time in this process, and you get tired. And yeah, you probably already understand what I'm alluding to. So we are regularly profiling our collectors. We're using pprof extension to do this. And here I have some recent flame graphs from memory and CPU usage in our central Datadog collector. And what we see there, because I appreciate you don't really see what is on the flame graphs themselves, so we see that the majority of the CPU cycles are being used in marshalling, including garbage collection, and also a lot of memory is being spent in this process. So the idea is beautiful that that OpenTelemetry collector is very modular, and that we have OTLP coming in and out of all components, but the transformations that are needed to achieve it are very resource intense, and this is not a benefit, I would say. And then the third pain that we have experienced is the necessity to add additional infrastructure components to enable the correct functioning of some stateful components in the OpenTelemetry collectors. For example, in the central OTLP collector that we maintain, we use span metrics connector, and it's a very nice component that allows generation of red metrics from spans. And for this component to work properly, we need to ensure that spans belonging to the same trace are coming to the same collector pod. So because of this, we had to deploy a special collector in front of that collector that has a load balancing exporter and enables this functionality. So it sends all the spans with the same service names, span kinds to the same collector pods. And yeah, we need to maintain, observe, and debug this collector in case it's faulty. The same way we do with the delta cumulative processor. So we use it in the central Datadog collector. And this is a processor that allows conversion of metrics with delta temporality to metrics with cumulative temporality. So it's stateful because it accumulates deltas. And for this component to work properly, it needs to know from which Datadog host, in our case, the payload is coming. So that all the deltas belonging to the same host are being accumulated on the same collector pod. And for this, we, again, had to deploy custom infrastructure components. So we have a custom proxy application that passes the payloads, extracts Datadog hosts into the special header, and then we have a header-based routing on Istio configured that Istio is in front of the central Datadog collector, and it takes all the requests with the same routing key header and sends it to the same collector pod. And this is the pain because, again, we need to maintain custom proxy application. It just had a major to our incident yesterday, by the way. Congratulations, team. This is really a pain, right? So now I want to summarize again the pains and the learnings that we had. So we frequently need to customize contrib components, and I don't think that it will go away anytime soon. Also, stateful components frequently demand a special infrastructure that needs to be observed and maintained, and collector by design spends a lot of time and other resources in marshalling and non-marshalling data. And these are real challenges. But despite these challenges, we're still enthusiastic about OpenTelemetry, and we think that basically it's the only means that allow us to get to our strategic observability goals of becoming vendor-agnostic and eliminate vendor lock-in. And to conclude this session, I want to leave you with the following quote from Mike Tyson. Everybody has a plan until they get 1 billion active series in the face. So we might have, it's not a quote from Mike Tyson, just to be clear. we all have our great plans, and we all have our own visions of how we are going to use open source standards, and magically they're going to solve our problems. But reality is different, and there's always a certain overhead into customizing or adapting the standards to your own infrastructure and your own organizational needs. But it does mean that this path is not worth it. So I think in Delivery Hero's case, it's worth it. And yeah, with this, I would like to thank you. And this is it. Yeah.
OK, thank you, Elena, for a great talk. We have time for a question or two. So if you have questions, yeah, I see a hand here. There's a mic in the middle of the room. So yeah, please queue to this mic.
Hello.
Hello.
So in terms of collector contrib, obviously if you want to fork to put like company-specific logic in there, you know, that's a choice. But in terms of making contributions easier or making it friendlier to contribute things upstream, what are things that OpenTelemetry collector contrib could do to make that experience better, in your opinion?
Yeah, so as far as I remember, for at least 2 of these components, we have submitted, or some engineers from my team submitted pull requests to the contrib components, and I think one of them is still hanging there for like since 4 months or so. And the pace of such a migration as we did have in Delivery Hero, it's just so fast, it has to happen tomorrow. So to reduce this review cycles would be a great step towards making it more contribution friendly.
Cool, thanks.
Thank you. Almost the same question. How confident you are, Delivery Hero, in your ability to get your changes back to the project component so that you can stop forking? So you just told us it takes time. Are you confident that it's still a good path forward, or?
Yeah, it's only because, I mean, Delivery Hero is a company that we also have our own deadlines, right? We have our own goals, and we all have our things to achieve or promises that we made to CTOs and other talking heads in the company. So, and that's why we cannot wait for something that naturally takes long, but yeah. We're confident that we can contribute, but sometimes we need to first integrate it in our systems. It's also a nice way, by the way, to battle test some components, because sometimes they are being implemented maybe with a small chunk of data, and we have a large volume of data that we can immediately pipe through these components in our collectors and test whether or not the implementation works and makes sense and is efficient.
Hi, thank you for the talk. On the same note, I was also interested if you could elaborate on what changes did you need to make to the Prometheus remote write exporter in your fork?
It was a very small, maybe ask me about it after the talk. It was a very small change. I remember, yeah, it was a very small change. So we had an issue with the Prometheus remote write exporter, and the problem was not logged. So we introduced logging into this exporter to debug the problem that we had.
Thank you.
OK. It seems we are done with questions, unless anybody wants to run to the mic. No? OK, thank you, Elena.
Thank you.
And we will be back shortly.